Ruiz, who's an astrophysicist. I was just telling Kiara, I remember going to one of my first laser talks in 2009, I guess it was, at Stanford, or at San Francisco. So it's fun to continue to drop in and to see things moving forward. And I'm really glad that you're all here. I'm doing something a little different for myself as well, as opposed to sort of walking through, this is what I do. I'm kind of playing with the idea of starting it off as a kind of story and bringing you through the work and the projects that we've been doing without talking about specifics, knowing that you can look at the website for this work. I'm going to be introducing the Algae Society, which is something that's been going on since 2014, roughly 2018. So bear with me, there's some storytelling here, which is a little bit different approach for me. So the planet began as a dark sphere, heavy and wet, thick and choking gases, relentless heat. No eyes to witness it, no lungs to breathe, only the slow churning of matter, volcanic breath and waves endlessly slapping against rock. Then in a shallow place where ocean touched sky, something began to drink the light. It stretched, it split, and it multiplied into billions. Poison in the air became life. Algae released oxygen, transforming the atmosphere. Water thickened into green, and algae grew bold, creating underwater forests of towering kelp that danced unseen beneath the waves. Fish arrived next, breathing the oxygen-rich waters, followed by creatures that emerged from the vital exchange between algae and air. And now the climate is changing again. Heat remains trapped where it once escaped freely. Storms intensify and ice withdraws from the poles. Oceans sour, burdened with carbon, tipping the balance toward uncertainty. Algae bloom unprecedented ways, yet near volcanic shores, warmed by excess CO2, a resilient strand of cyanobacteria thrives. Absorbing carbon rapidly, it grows heavy and sinks to the ocean floor, locking carbon away and renewing the cycles of oxygen. In quiet waters along ancient shores, algae dwells, ubiquitously embodying resilience, reflecting an algae's crucial role in shaping our planet's atmosphere. In 2014, Jean Felice, a graduate student, and I developed Oceanic Scales, an interactive exhibition and platform highlighting the beauty and wonder of phytoplankton. From this collaboration emerged the Algae Society in 2018, a global collective blending artistic insight, scientific inquiry, and community wisdom. Turning toward algae not merely as objects of study, we see them as a companion species whose subtle strengths illuminate pathways towards ecological understanding, inviting us to reconsider our place within nature's delicate tapestry. At a moment when environmental protections falter under political currents favoring extraction over preservation, algae persists quietly, absorbing carbon, exhaling oxygen. Among Earth's oldest organisms, algae produces roughly half the oxygen that we breathe, cleanses water, stabilizes environments, and thrives under ecological stress. Their resilience reflects an adaptability required of humanity, urging humility and thoughtful stewardship. Through immersive interdisciplinary projects, public engagements, the Algae Society invites community worldwide to reimagine their connections to this remarkable organism, fostering harmonious and informed interactions with our environment. So we have tons of projects. Again, I invite you to go to the Algae Society website to check them out. I don't really have the bandwidth in our 20 minutes to talk about each one, so I sort of wanted to give you an overview and being able to see it. but I will go into more depth a little bit of a project that I started last summer. I commissioned a traditional glass blower, Diego Rodriguez Blanco, to collaborate for 1 week with my colleague and former graduate student Jose Carlos Espinal, who is at the BioArt in Madrid at University Complutense. And together we worked with Diego in his vibrant studio nestled in the hills of Segovia, Spain, which is just an hour north of Madrid. And our goal was to create blown glass sculptures inspired by algae, designed and informed and guided through collaboration with artificial intelligence. And this experimental project traced the relationship between nature and technology, form and possibility, inspired by flowing patterns of seaweed, and transformed through AI and molten glass, revealing new ways of thinking about adaptation and creation in a changing environment. Glass and algae share a profound connection, rooted in adaptability, fragility, and responsiveness to light. Algae's intricate organic forms, shaped by environmental resilience, inspire the fluidity and transparency of glass. Both materials interact with light. Algae is transforming it through photosynthesis, glass refracting and playing with it, creating a dialogue between natural growth and crafted form. Algae's silica-based structures even echo glass material origin, forging literal and conceptual links between the two. Through AI, seaweed's forms were reimagined, giving the master glass blowers a framework to craft works balancing the organic with the artificial, the natural with the technological. This integration of AI opened a critical conversation about ethics and the environmental impacts of technology. We consciously reflected on the energy-intensive processes underpinning AI's computation and glass production, exploring ways to critique and discuss these effects as integral conversations to the work. The act of blowing glass, a fragile vessel formed by human exhalation, echoed here, tied to the larger exchange, carbon given, oxygen received, algae at work, sustaining life on Earth. A sound artwork created with an opera singer, David Aller, engulfed the gallery, folding into the rhythm of the works as a shared breath, speaking to, I don't think we have sound, oh well, speaking to the cycles of life and the moment of boundaries blurred, human and non-human, creation and necessity, all part of the same system, each breath a reminder of our place with the planet's intricate choreography. From the corner of the room, a ringing bell cut through the air, and the resonant tone sounding the alarm, pointed sharply to the polycrisis of a changing climate. The clarity juxtaposed the fragility of the material. The bell's voice became a call to attention, urging us to listen to the cycles like cracks and the possibilities of transformation in the face of environmental upheaval. So this last piece I'm going to share with you, I was going to take my 20 minutes, but I'll see what the vibe of the room is because it's small. It's kind of a meditative piece. I was feeling like the ways in which news is coming at us constantly and we're all in a sort of state of shock, that having a moment to meditate on algae would be healing and perhaps even enlightening. And so this last piece I'm going to share with you, I created using scanned seaweed and intricate drawings of diatoms to create a kaleidoscope tapestry paired with flute music by Leon Studios in Buenos Aires. And I picked the flute because it's also the earliest known instrument, a wooden flute. So I thought it paired well with algae. And through this work, the timeless rhythms of algae are brought into the present, offering a moment. Ooh, will we have sound? We need sound for this. The present moment, offering a moment of reflection that links the evolution of life and the shifting ecologies of today. It's both a meditation and a call to recognize the connections that shape the living world across time and space. Maximum power. Let's see. stop it there and acknowledge that that is a different version of the one that I thought I was sharing. Obviously the music is not what I thought it was. If you guys were all like, where's the wooden flute? That is a different one. So I thought I would end there, and we can go. Was that abrupt? Sorry. No. And go into conversation about the Algae Society or Open Lab or anything that folks would like to talk about.
So this society is supposed to be a number of labs around the world that work on that subject, right? But what kind of collaboration do you envision among these labs?
So, I mean, again, the project started with a graduate student who was already working with phytoplankton, and we were looking at ocean health and ecology. I have like 5 different fish glasses on each one. These are 5. And really trying to understand how arts could play a role in climate action or climate sustainability, and the ways in which we could bring attention to what's going on in the ocean health. And so phytoplankton was where we started, and that was with a graduate student, and we did some funding and did some projects there. And then we had an opportunity to do an exhibition at this place called Moxie, which is in Santa Barbara. It's an art and science museum that's intergenerational, so it's actually kids-based, which is the spaces that we've come to occupy the most, as sort of science museums and planetariums. And it was, how do we think together with others around this theme of bioart and technology, and with algae as the focus. And so several of the people that I had already been working with were now starting their own labs as young professors or researchers at different institutions globally. And so I reached out to them and said, okay, well, what if we had somebody in Australia, someone in Norway, someone in New York, someone in North Carolina, someone in Sweden, and how we could then start to think collectively about what it means to create work with algae as a companion species. And then sort of each location would spearhead their own project and say, oh, okay, I got a venue, I've got a group of people who want to make projects. And so it becomes really hyper-local in that way, and folks who wanted to experiment or play with, whether it's from a sort of making, bioplastics and playing with materials, or making art about the work or about the ocean or interspecies relationships. So it kind of just grew from there, and having different shows and getting museum exhibitions, but also really keeping a focus on intergenerational spaces, so that it was for kids to have a conversation around what it meant to think about algae as a companion species, as well as their caregivers, so that there'd be these ways in which we could sort of be educating both people or inspiring both people to want to learn more.
Yeah, it's very interesting you focused on algae, because people would focus on all sorts of living beings, not on algae. You said they absorb carbon, but correct me if I'm wrong, they absorb 1/3.
1/3. We looked into this, and there are debates, I'm sure other people here will have that, but we were told 1/2, close to a half
of the carbon dioxide.
Yeah, so the oxygen, 1/2 of the oxygen that we consume, so I don't know what that translates into the amount of carbon that's absorbed, but there is this newer algae or cyanobacteria that was discovered it's called chunku, something like that, because it's so chunky that it is absorbing more carbon than any other cyanobacteria before, which is really interesting that this is sort of springing up in this carbon-rich environment.
Okay.
What do you think of genetic engineering approaches to algae where they're trying to get them to absorb more carbon?
Yeah. I mean, it's interesting because we have the Genomics Institute at UC Santa Cruz, and we've been collaborating with them, art and genomics as well. And so learning more about what genomics is, and also, I think it's really, they don't have a good sequencing of algae. I think it's one of the harder things to sequence, or it hasn't been sequenced. But yeah, any kind of biotech that we get into these debates, right? Should we geoengineer the world or not? I don't know. I don't have those opinions per se, but I think it seems like with this new cyanobacteria that algae is pretty good at saying, oh, you need us to do more work, we'll step in and do that. We love to multiply and take up space and all of that. So it seems like already it's modifying itself based on the environment.
How do you plan to present the work at some point? For those who don't know, Open Lab UC Santa Cruz first of all, it's a very interesting lab. probably unique of all the art science initiative I know. And they also have organized events, public events, right? I remember the one just before COVID.
What Makes Us Human.
Yeah.
That was an online virtual exhibition. I mean, we are always having exhibitions, and we're always trying to do stuff. Like one of our current projects now, which of course there's algae and everything, and always like, oh, where's the algae? Is we're harvesting water from the sky, and we're looking at fog catchers because of this unique environment. Working with a chemist who was trying to understand why the mercury level at the farm at UC Santa Cruz had so much, or why the soil had so much mercury and why the levels were so high. And he's a chemist, and he was like, well, maybe it's in the fog. And so he got into fog catching, and it's basically a giant net. And so when the vapors go through, the fog goes through the net, the tiny vapors collect into bigger droplets that you then eventually fall and you can collect. So it's not maybe something that we think of in this area because we have somewhat plenty of water, but for arid locations and people looking to collect clean water without needing anything but a net, so it doesn't require any electricity or anything like that, it's becoming a more and more interesting opportunity for harvesting water. And it was a big push, I think, like in 2014, 2015, I think there was more money put into it. So when you look at fog harvesting, you see all of this stuff, and then you're like, well, what happened to it? I think the money dried up, but I think there's now a resurgence of it. So we were looking at it like making more interesting objects, and we just put a cloud-shaped fog catcher as a public art project in front of the Seymour Center, which is part of our coastal climate. So getting people to think about it, because you could put a fog catcher in your backyard if you live in San Francisco and pretty much water your garden with that. You can get a decent amount of water that way. And it's just a net.
Probably play devil's advocate, but our assumption that we want to preserve certain species rests on the fact that things are static maybe, but we do know that we exist because some other species at some point died out. So what are your thoughts on wanting to stick to a certain nostalgic sense of ecosystem versus allowing what is going to flourish in the upcoming situations to grow?
Yeah, I mean, I think they look at that even in the natural parks, right? Like, we need to keep it like this, and that's not a kind of realistic way of thinking, I don't think. And, even the term invasive species is something that we are trying to tackle and understand. Are they just a super species, and they're doing really well? Don't blame them. But, I think part of that is this tipping point of balance, right? Like, we don't really know what happens if you get rid of one species. How does that affect everything else? And I think that's maybe the cornerstone for the biologists and the scientists who are trying to navigate that. If we lose too much, will it then, just thinking about harvesting water, like part of what we want to do is create water or fog catchers for bees and birds and migrating animals to be able to have access to water. And that also would include the animals that would come through the San Francisco and Santa Cruz County to eat or feed off of those species. So it's this whole ecosystem, and it's so fragile that I don't know that we don't have the answers to these things. System collapses. Maybe it's fine. Maybe it's not. Like I imagine just seeing the way the temperatures have shifted, that alone is suggesting it'll be hard for humans to stay. So I think looking at species past and how they've survived is one model of considering how to navigate the preservation or not.
Okay, very good.
All right, thank you.